Hello everyone, my name is Martijn Kuller, and today it is my honor to talk to you about stormwater in our cities, or rainwater, and how to turn it from a burden into a benefit. Before I start, let me first quickly introduce myself. I was born in the Netherlands, and since I was a little kid, I've always had a fascination for geography, especially the geography of cities. And throughout my studies and career, I've tried to combine this interest with my other interest in sustainability. So during my PhD at Monash University in Melbourne, I've studied the interface between urban planning and urban water management, and very aptly I graduated back in 2019 in the rain, as you can see in the picture. Because of my fascination with cities, I've lived in different cities, from small, like Wageningen in the Netherlands, to big, like Melbourne and Sydney in Australia. And I'm certainly not the only one, because now half of the population in the world lives in cities. And this number is only going to increase into the future to about 70% by 2050, mainly due to the rapid rise of the cities in Africa and Asia. In Western countries like Switzerland, the urbanization rate is already very high. Switzerland is 74% at the moment. But all these people that live in these cities are under threat. Flooding is by far the most important natural hazard, and over the past 30 years, urban floods have quadrupled, according to the World Bank. The damage caused by floods has increased even more over those 30 years, and this is also projected to increase even further into the future. Now, cities are actually the places where these effects are felt the most, just because of their density of population and density of property that can be damaged. At the same time, cities around the world are grappling with the effects of increasing droughts. In 2018, the Cape Town government announced the coming of day zero, where the water would run out. And at the beginning of this millennium, we had a very severe drought in Australia called the Millennium Drought, where there were very severe water restrictions being put into place. But also here, we're actually for the third time in a row in a drought in spring in Europe, and you can see the effects that it has on my lawn. Heat is another threat. Here on the map, you can see a picture of the city of Zurich in 2017 in a heat wave in June. And you can see that the inner city parts are significantly warmer than the surrounding areas with green space. And this effect is called the urban heat island effect, where cities over daytime capture the heat of the sun, and then during the nighttime release it slowly, causing these inner city parts to be much hotter than the surrounding. Now, this particular heat wave actually caused 1,000 people to die in Zurich. The following problem might not resonate so much with people in Switzerland, because the waters here are crystal clear, but in large parts of the world, cities are not blessed with these clear waters. So I remember living in Sydney, close to Coogee Beach, which is one of the most famous beaches of Sydney, probably the most famous after Bondi. That after a long dry period, followed by an intense rain, that there would be a newspaper advertisement saying, "Don't go swim on Coogee Beach." And this was actually caused by the stormwater that was released into the ocean, because Coogee Beach is right next to the outlet of a stormwater sewer. And so the pollution that then washes off from the urban surfaces includes mostly phosphorus and nitrogen, which has a negative effect on the biodiversity in water, but also things like heavy metals and even pathogens, which makes the water very unsafe to swim in. Increased urbanization, of course, leads to a decreased amount of green space, which actually has a very significant impact on people's health and well-being, besides, of course, the decline in biodiversity. Now, there are some exceptions of cities that have a lot of green space, such as Moscow, Singapore, and Sydney, where almost half of the city is covered by parks and gardens. But In a majority of cities, this percentage is much lower. In extreme cases such as Dubai, Istanbul, and Mumbai, this percentage is only 2. Now, all this havoc is caused by 2 main drivers. The first one being climate change. Climate change leads to more intense rainfall, causing floods, but also longer dry periods, causing droughts. And it leads to more and longer heat waves. Now, climate change is an external driver that local governments, city governments, can't really influence. So that is the bad news. Now, the good news is that city governments can influence the second driver, which is urbanization. And I'm talking mostly about the quality of urbanization in this case, because the quantity of urbanization is a bit more hard to restrict. But the quality of urbanization is something that city planners can actually influence with how they manage the city. And water management is actually a major part of this. In a natural environment, this is what happens to rain. About 40% of it evapotranspirates, then 25% of it infiltrates into the soil and is available to plants to grow, and 25% goes into deep infiltration into so-called aquifers. Then 10% remains, which runs off into rivers. Now, in an urban environment, this water cycle is heavily altered. So of the rain that falls in the city, about 30% is evapotranspirated. 10% goes into shallow infiltration in the soil. 5% goes into deep infiltration, which leaves about 55% to run off directly into rivers. So this heavy increase in runoff makes cities much more prone to flooding, while the decrease in evapotranspiration helps actually make cities more hot because evaporation cools down an environment. And then the decrease in the infiltration actually makes cities also more prone to droughts because there's less water stored in the soil that can be used in periods when it doesn't rain. So in order to decrease all these problems, we want to actually move from the situation on the right back to the situation that is more natural on the left. But how can we do this? One way of doing this is to move away from the traditionally used gray urban water infrastructure, where we put the water literally in the gutter and then it moves to the sewer system and as quickly as possible into the urban waterways, to move to more decentralized green-blue infrastructures. Now, these green-blue infrastructures can simply be parks with a lake or a garden with a pond. But over the past few decades, civil engineering research has focused on designing green-blue systems that are specifically made to improve the processes of bringing the natural water cycle back into the city. These systems such as wetlands, bioretention systems, and green roofs, they retain the water in the city, and thereby it has more time to infiltrate into the soil, it has more time to evaporate and cool down the city, and it can also be used to recycle and actually, for example, irrigate urban spaces like sports fields. Now there's a number of these systems around. For example, these rain gardens that are also called retention systems or biofilters. An example of a rain garden I'm showing here in the picture on the bottom of the slide. This picture I took in Oerlikon, where I live. And as you can see, this biofilter is a little bit lower than the surrounding area, so that the water flows into this biofilter instead of flowing into the gutter. And then it goes through several layers of filter media that take out some of the pollutants that can be found in rainwater, in stormwater. And at the same time, they're planted with specific plant types that take up the phosphorus and nitrogen, which is 2 of the main pollutants found in urban stormwater. And plants use these nutrients to grow. Once the water filters through this biofilter, It can then be infiltrated safely, or it can be put into a sewer and released into the natural waterways, or it can even be recycled and used to do irrigation, for example. Another system that you'll all be familiar with is ponds and lakes. So in the picture in the bottom, you can see a lake that is in Oerlikon again. And it takes the water from this residential area behind it, and in a very severe rain event, all the water will flow in the lake instead of flooding the streets of this residential area. And then at the same time, the water will stay in the lake for an extended period of time, which means that the coarse material, the coarse pollutants, will slowly sink to the bottom, and the water that then flows out of the lake eventually back into the natural waterways is cleaner than when it came in. Then a more advanced system are wetlands. In the top right picture here, you can actually see a wetland in Melbourne. And you can see that the water has to follow a specific course. And along this course, different water depths and different plants are used to clean the water, just like the biofilters are doing. Because the water has to run through this course, it also stays in the city for longer, and it in the end can then be slowly released into the natural waterways. And finally, we can green up the buildings of the city themselves. In the bottom picture, you can see an example of a green roof. This is actually my bike storage of my apartment. And on the right, you can see a green facade of an apartment close to me. And these systems are actually ideal for places where there's not a lot of space, so in dense urban areas, because they can just be built on buildings themselves. And if they're designed properly, they can fulfill the same function that an urban wetland, for example, does, because they can retain the water, they keep the water in the city, and slowly treat it, clean it, and then release it. Cities around the world have started implementing these systems, although very slowly over the past decades. But they're called different in every part of the world. Here in Europe, they're called nature-based solutions, while in Australia, where I studied them, we refer to them as water-sensitive urban design. In China, they use the analogy of a sponge, which I personally find really apt. So they call it Sponge City, and they're currently investing billions of dollars to turn, I think, 38 cities, major cities, into these so-called sponge cities. In the United States, these systems are referred to by low impact development, whereas in the United Kingdom, they use sustainable urban drainage systems. So it's called differently everywhere, but it all refers to the same thing. All the different approaches and different technologies have a few things in common. They'll use plants, and they retain the water and clean the water. They recycle the water, and they're decentralized and therefore more flexible, increasing the resilience of cities, buzzword. And they have a large number of economic and environmental benefits. So economic benefits include flood protection, which leads to lower damage costs, but also it has actually been shown that houses around rain gardens or biofiltration systems, this study was done in Sydney, that houses are actually tens of thousands of dollars more in value than without those rain gardens. So there's these direct economic benefits. And at the same time, there's a lot of environmental benefits with decreased pollution into our natural waterways, increased biodiversity, and there's of course also the cooling of our cities and the increased amenity of having more green space in your city. That makes a city more attractive and gives people space for recreation. So if we know all these benefits and we have these technologies available to us, why aren't we using them more? Well, the answer is simple. The current traditional urban water systems are underground, while these green infrastructures are above ground, and so they're not so simple to implement, especially in dense existing urban areas. To make these systems successful, there's a lot of different things that need to be considered in the urban planning. For example, what is the local hydrology? Where does the water flow to? What is the slope? But also, what is the acceptance of the people that live around these systems? Will they be able to appreciate these systems? Where is space available? And what is the price of land, and can we afford to build a system there? But on the other hand, also, where do we need all these benefits that we get from the systems? Where can we use the recycled water, for example, to irrigate sports fields? Where are the hottest spots in the city that we can cool down using these systems? Where is there a big lack of green space, and where could the city really benefit from increasing this green space? And even where are biodiversity hotspots? So all these things need to be taken into consideration when we place these systems in the city. Because the planning for these green-blue systems is so highly complex, in many cases, urban planners resort to what they know, which is just implementing gray systems, sewer systems. And even if they implement green-blue systems, they often do it very randomly. So they just place them wherever they find space or wherever they're redoing a park. So because of this, a lot of people in academia have started thinking of ways to help urban planners improving their planning processes. And one of these people was myself in my PhD. And what I've come up with is a very simple model, a spatial tool that is called SANTO, a spatial suitability analysis tool, which gives urban planners this map, which you can see here, that has a simple color code indicating what are the very highly suitable and the less suitable locations to implement a specific green-blue system in the city. Slowly, cities around the world are becoming more green-blue, and the good news is that everyone at home can actually contribute, for example, simply by removing tiles from your garden and putting a plant in place. I know in my home country, they actually have a program where you can bring tiles from your garden to the municipality, and in return for these tiles, you get free plants to put back in your garden. Recently, only like 2 weeks ago, I saw on the Swiss news actually that the city of Zurich is also implementing a big urban greening program, which I was really happy to see. Their focus is more on urban cooling for the hot summer days, but the principles are all the same, and the increase of green-blue spaces will also help with all the other issues that cities are facing. So with that, I would like to end, and you can reach me through email and look me up on LinkedIn. I'm happy to answer any questions that you might have.